Hello everyone, this is Mr. Manideep Gupta, Assistant Professor, Department of Aeronautical Engineering, MLR Institute of Technology from Hyderabad. Okay, today we are going to discuss about the subject Aerospace Propulsion 2. In this, I am going to give an overview of basic fundamentals which are essentially required to understand the Aerospace Propulsion 2 subject. So, coming to the today's overview of presentation, we are going to discuss about the introduction to universe, Milky Way, galaxy, what is galaxy, and the way how like a Earth evolving, like a Earth, the position of Earth in the galaxy, solar system, and law of planetary motion. So, these are the topics which we are going to discuss today in a brief manner. Coming to the first one, introduction to universe. So, universe is actually endless. There is no starting and there is no end for the universe as we know. Okay, coming to the whatever the observable universe which we know till now, right. So, here there are around 10 to the power of 11 galaxies, that is around 100 billion galaxies are there in the observable universe. So, these are only just whatever we found, that is around 10 to the power of 11 galaxies, and still there are so many but which are not observable. Okay. So, there are just observable galaxies, around 100 billion galaxies. Okay. And coming to the galaxy, what is galaxy and what is the size of galaxy in this universe, right. So, coming to the galaxies, in that galaxies there are so many galaxies, and Milky Way is also one of the galaxy, which is one of the galaxy, and this is our galaxy, right. Coming to the Milky Way, coming to the size, the diameter is around 10,000 light years and thickness is 2,500 light years. So, what is light year? Okay, light year is nothing but the distance travelled by a light in 1 year is nothing but light year. Just imagine, if you consider 1 year equal to 365 days and each day has 24 hours and 1 hour has 60 minutes and each minute has 60 seconds. If you calculate like that, 1 year will have around these many seconds. Okay, 3 crore 15 lakh 36,000 seconds. If you know, if you are going to the speed of light in the vacuum, that is around 3 into 10 to the power of 5 kilometers per second. Just see here, the light velocity is 3 into 10 to the power of 5 kilometers per second. In 1 second, the light will travel around a distance of 3 into 10 to the power of 5 kilometers. And if you imagine the distance covered by the light in 3 crore 15 lakh 36,000 seconds, that is 1 light year. And if you calculate the distance that is being covered by a light in 1 year, here is the distance, that is 9.5 into 10 to the power of 12 kilometers, and that is 1 lakh crore kilometers. So, 1 lakh crore kilometers is considered as 1 light year. Just imagine the distance. Like that, the diameter, if you consider the light year is 1 light year is 1 lakh kilometers, 1 lakh crore kilometers. If you go to the diameter of the galaxy, if you go to the diameter of our Milky Way galaxy, that is 10,000 light years. 10,000 light years. That means almost 10,000 lakh crore kilometers distance, diameter the Milky Way galaxy is, and coming to the thickness around 2,500 light years. Just imagine how big the galaxy is, one galaxy is. Like this, there are n number of galaxies. We have gone through this, right? 10 to the power of around 100 billion galaxies are there in this universe. In that universe, Milky Way is just a galaxy which has a size of 10,000 light years diameter and 2,500 light years thickness, right. So, generally what is galaxy and what a galaxy consists of? A galaxy consists of stars. Everybody knows about stars. Star is an illuminating body which generates light, right. Coming to our star, what is our star? Sun. Sun is our star. And also galaxy consists of interstellar gas and dust. What is this interstellar gas and dust? Suppose if you consider one star here, another star here, definitely there will be some space, okay, even though consider the star size is very big. Whatever the gap in between these two stars, that will be occupied by a very thin gas, which is a neutral helium generally. Okay, that whatever the gap occupied by between the two stars, that is nothing but interstellar gas or dust. So that is also one part of galaxy. And black holes. Black holes is also one part of galaxy. What is black hole? Black hole is nothing but a dense matter, very dense matter, which has a very huge gravitational force, huge attraction force, such that a black hole can absorb light. Once a light enters into the black hole, it cannot come out. That much attraction power a black hole has. So black hole is also one of the part of galaxy. And quasi-stellar radio sources. Quasi-stellar radio sources are nothing but a compressed star. So if you have any star and if the size of the star is compressed to a very small particle size, then that is nothing but a quasi-stellar radio sources. So this also emits radiation, but the size is very small. Okay, these are quasi-stellar sources, which is almost like a star, but the size is compressed star. We can call it as compressed star. And next, unseen dark matter. So there are so much matter in this universe which is not interacting with the light and also not interacting with the electromagnetic field. So which is not able to observe by us, which is nothing but the unseen dark matter, which is not able to observe by the human. That is also there in the universe. And plasma. Plasma is nothing but an ionized gases, whatever the material which is ionized. Okay, neutral means full of electrons, and ionized, if one electron comes from any substance, that is called as ionized. So this plasma is ionized substance. So these are all the parts of galaxy: stars, interstellar gas and dust, black holes, quasi-stellar radio sources, unseen dark matter, plasma. All these are the parts of galaxy. And if you come to our galaxy Milky Way, even Milky Way also has all these types of matters in our Milky Way. So Milky Way is one galaxy and Sun is our star in the Milky Way galaxy. There are around 100 to 400 billion stars like Sun in our Milky Way galaxy. We know Sun is our star, right? And Milky Way is our galaxy. But like Sun, there are around 100 to 400 billion stars in our Milky Way galaxy. And only 10% of the stars have planetary system like our solar system. Only 10% of these 100 to 400 billion stars has planetary system like our solar system. Everybody knows about solar system, right? So even though we will discuss about solar system also. Solar system. What is solar system? Solar system is nothing but Sun is a center and planets revolving around the Sun in an elliptical path, which is called orbit. Okay, coming to the solar system, our solar system, Sun is the center and there are 8 planets in the solar system. Okay, there are 8 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Even Pluto was there in previous, but it is not considered as a planet now. So now we have 8 planets in our solar system. Okay, all these planets are made of rocky, liquid and gaseous substances. You can take any planet, it can be either made of rocky, means solid particles, solid, liquid or gaseous substances. Okay, along these 8 planets, Earth is also one of the planet in our solar system, which is positioned in the 3rd place from the Sun. So each planet follow a particular path around the Sun, which is also called as orbits. So here you can see in a picture, these are all the planets these are following this particular paths which are called as orbits. And coming to the solar system, we have 8 planets, right? Mercury and all this. Each and every planet has some mass and some specific size. So here we have given mass and diameter of the all planets. In that, if you take the Earth, which is our planet, if you take the mass of the Earth, it is 5 into 9.74, 5.974 into 10 to the power of 24 kgs, and coming to the diameter 12,756 kilometers. Diameter in the sense like that, this is diameter 12,756 kilometer diameter for the Earth. Coming to the mass, 5.974 into 10 to the power of 24 kgs, and around 31 known moons, that means satellites, moons revolving around the planets in our solar system. In that, our moon has 7.348 into 10 to the power of 22 kg mass, and coming to the diameter, it is 3,476 kilometers. Right? Everyone has to remember, everyone has to go through these masses and diameters of each planet, because these are very important parameters for the planets, by which we can calculate the gravitational force of attraction. Suppose if you want to send any satellite to any other planet, we should know the gravitational attraction of the particular planet. In order to calculate the gravitational force on a particular planet, we should know this parameter, mass and diameter. These are the essential parameters to calculate that. So very important data to be remembered by everyone. Next, time periods and distances from the sun. Okay, Mercury, it is around 0.241 years. What is year? Year is consisting of 365 days. It is according to the Earth rotational speed. Okay, and the distance is 0.39 astronomical unit. Mercury is at a distance of 0.39 astronomical unit. What is astronomical unit? The astronomical unit is nothing but the distance of sun, from the Earth. The distance of the sun from the Earth is nothing but 1 astronomical unit, that is 150 into 10 to the power of 6 kilometer. Okay, like this, Mercury is around 0.39 astronomical unit distance from the sun, and Earth has a moon, and coming to the next one, the Earth has a moon which is at a mean distance of about 3,84,400 kilometers from the Earth. Okay, and the Earth's moon travels around the Earth with a mean velocity of around 1.02 kilometers per second. Okay, so these are the time periods, distances, and this is the distance of moon from the Earth, and this is the velocity with which the moon is traveling, moving around the Earth. Next topic is laws of planetary motion. Okay, there are basically 3 laws of planetary motion: laws of eclipse, laws of equal areas, and laws of harmonics, which is said by Johannes Kepler. Okay, so let's see with the first one, laws of eclipse. The paths of a planet in the solar system about the sun are in elliptical path, and the center of the sun being located at the focus. So if you take any planet which is revolving in a elliptical path like this, and sun is at the center. So this is the law of eclipse, which is said by Kepler, first law. The second one, law of equal areas. What is this law of equal areas? Suppose if you consider this an elliptical path followed by a planet, and this is the center, consider this as the sun, and we consider a planet. Okay, here planet, these are the different positions of the planet, position 1, position 2, position 3 and position 4. Let us say if you join a line from sun to the planet at position 1, this is the line, and if you join the lines at different positions, okay, these are the lines, right, and if the planet covers a area from 1 to 2, okay, the planet has travelled from 1 to 2 and the time taken by the planet is T1, and the area swept, this is a hatched line, consider this as A1. The planet, whatever the line joined from the center of the sun to the center of the planet, swept an area A1, and the time taken for the planet to move from 1 to 2 position is T1. Okay, and let us say the planet is moving from 3 to 4, okay, 3 to 4 during a time of T1 second, then this area will also be equal to A1. So, a planet, the imaginary line from the center of the sun to the center of the planets sweeps out equal areas in equal interval of time, equal areas in equal interval of time, equal areas, that is A1, equal interval of time, that is T1. If a planet travels a distance or travels a duration of time T1, if it occupies area A1, whatever the positions, if it travels duration T1, it will occupy the area that is equal to A1. That's it. This is the second law, law of equal areas. And the third one, law of harmonies. The square of the orbital periods. Suppose if you consider the orbital period is T, okay, square of the orbital periods, that is T square, of the planets directly proportional to the cubes of semi-major axis of their orbits. What is semi-major axis? Okay, this is major axis, half of the major axis is semi-major axis, that is capital small a. Okay, this is small a and this is small a, and the major axis is 2a, semi-major axis is a. So, the squares of the orbital periods is directly proportional to the cubes of the semi-major axis, that means a cube. The time period, the square of the time period of the planet is directly proportional to the cubes of the semi-major axis of a particular elliptical orbit. This is the third law. Okay, these are the laws of planetary motion by which we can analyze the position of the planet at different times. We can easily estimate the position of the planet after some 5 years, and we can easily estimate the position of the planet after 3 months, if you, with the help of these 3 rules. These rules help you a lot for us to analyze the motion of planets around the sun. So, these are the topics which we have discussed. So, finally, if you go coming to the summary, we have discussed about introduction to universe, we have gone through the Milky Way galaxy, solar system and laws of planetary motion in today's discussion. And the next class we will discuss about the gravitational force. Okay, the gravitational force, what is the law of attraction between any objects in this universe. Okay, thank you.